press the bell icon on the YouTube app and never miss another update.
Hello students, we solve some application oriented problems with respect to the union and intersection of two sets. With respect to union and intersection of two sets. Before that, so we find one more formula. So to solve such type of problems, we need one concept that I treated as a formula. Okay, so we will see which formula we use for this concept. So I explain this formula by taking an example. See, observe here. Let set A has some elements 1, 2, 3, 4. It has some elements 1, 2, 3, 4. So total number of elements n of A is equal to how much? It is 4. So one more set I take B. It has some elements 1, 3, 5, 6. N of B is how much? It is also a 4. Not only 4, you take 5 elements, 6 elements, whatever it may you want. So then I find A union B firstly. So the A union B is what? 1, 2, 3, 4, 5, 6. Then total number of elements present in A union B is how much? 6. Correct na? Total number of elements present in A union B is 6. So one more I find A intersection B. Common elements. What are those common elements? 1, 3. N of A intersection B. N of A intersection B is how much? 2. Correct na? So what we do? We add N of A union B plus N of A intersection B. What we got the result? 6 plus 2 is equal to 8. Correct? 6 plus 2 is equal to what? 8. One more we add N of A plus N of B. 4 plus 4 is equal to 8. Observe these two. N of A union B plus N of A intersection B is 8. N of A plus N of B, that is also 8. From these two, RHS is same. That implies LHS is also same. LHS is what? N of A plus N of B is always equal to what? N of A union B plus N of A intersection B. This is a formula. We use this formula to solve some application oriented problems with respect to union and intersection of two sets. You remember this is a formula, very important formula. The formula says that N of A, observe here, N of A plus N of B. Let A and B or any two finite sets are right here. Let A and B are any two finite sets. Any two finite sets, then N of A, total number of element present in A set, plus N of B, total number of element present in B set, is always equal to N of A union B. That means total number of element present in A union B plus N of A intersection B, total number of element present in A intersection B. This is very important formula. So we always remember, and this concept one problem in an examination, annual examination for 3 marks. Compulsorily they ask 3 mark, one question regarding applications oriented on union and intersection of two sets. Clear now? So n of A plus n of B, it is always equal to n of A union B plus n of A intersection B. So see, observe here the concept. For any finite set, if you want to take any finite set, this result holds true. Clear now? This results holds true. For any finite set, if you want, you also solve. So n of A plus n of B is always equal to what? N of A union B plus n of A intersection B. I take one more example. A is equal to, it contains three elements, A, B, C. B is equal to D, comma, E. Here n of A is equal to 3. N of B is equal to what? 2. Then A union B. A union B is what? A, B, C, D, E. So n of A union B, n of A union B is equal to how much? It is 5. A intersection B. Any common elements? No, because these two, since A and B are disjoint sets. A intersection B is what? Empty. Then if A intersection B empty, it has no element, that implies n of A intersection B is equal to how much? 0. Total number of elements present in A intersection B is what? 0. Okay. So what we do? We add n of A plus n of B. n of A plus n of B. 3 plus 2. It is how much? 5. That is equal to, comparing these two results, that is equal to n of A plus n of B is equal to what? N of A union B. N of A plus n of B is equal to what? N of A union B. One more formula, n of A plus n of B, it is always equal to what? N of what? A union B. So when it is holds true only when A and B are disjoint sets. This is very important. Disjoint sets, that is A intersection B is an empty. It is holds true only when this formula holds true only when A intersection B is an empty. A intersection B is an empty means A and B are what? Disjoint sets. These two are very important formulas. First formula, once again I say that n of A plus n of B is always equal to n of A union B plus n of A intersection B. Second one, n of A plus n of B is equal to n of A union B only when A intersection B is an empty set. Clear the formula? So we solve the application problems with respect to the union and intersection of two sets. We will see the exercise. I think it is 1.6 exercise. Okay, today we are solving the exercise 1.6. Exercise. Under that, the first problem. So these are all very, very important for 3 mark in annual examinations. If capital X and Y are two sets such that n of x is equal to 17, n of y is equal to 23, and right below n of x union y is equal to 38, comma. What he asks? Find n of x intersection y. Find n of x intersection y. See the problem. X and y are two sets. Solution. You also solve. Solution. X and y are two sets. Given. Right, first given. N of x. Total number of element present in x set is 17. Correct na? Okay, comma. N of y. Total number of element present in y set is 23. Correct? And n of x union y is equal to what? 38. N of x union y is equal to what? 38. To find, what do you have to find? N of x intersection y. This is the problem. So what we know that just now we derived, if A and B are two finite sets, n of A plus n of B is equal to n of A union B plus n of A intersection B. So in terms of A and B, here are given x and y. So that x and y only write. N of x plus n of y is always equal to n of x union y plus n of x intersection y. N of x plus n of y is equal to n of x union y plus n of x intersection y. So substitute all the values, given values. 17 plus 23 is equal to 38 plus n of x intersection y. C is how much? It is a 10, 1, 40. Correct na? So 17 plus 23 is 40, 38 plus n of x intersection y. I shift 38 from right side to left side. That implies n of x intersection y is equal to 40 minus 38. Correct na? N of x intersection y, it is 2. See the problem. Very important problem for 3-mark question. Very simple problem. So I use the formula. So n of x plus n of y is equal to n of x union y plus n of x intersection y. Understand? So very important formula. First formula, n of x plus n of y is equal to n of x union y plus n of x intersection y. Second formula, n of x plus n of y is equal to just n of x union y only when x and y are disjoint sets. Understand the problem? Next problem. Second problem in exercise 1.2, if x and y are two sets, x and y are two sets such that x union y has 18 elements. X union y has 18 elements, comma. X has 8 elements and Y has 15 elements. Y has 15 elements. How many elements? How many elements does X intersection Y have? How many elements does X intersection Y have? Same type problem what we discussed in the previous problem, correct na? Okay, so solution. Given X and Y are two sides such that X union Y has 18 elements. That means n of X union Y is equal to 18. X has 8 elements. N of X is equal to 8. Y has 15 elements and n of Y is equal to 15. To find what? N of X intersection Y, correct na? N of X intersection Y. Okay, we know that N of X plus N of Y is equal to N of X union Y plus N of X intersection Y. N of X union Y plus N of X intersection Y. Substitute all the values. 8, that implies 15, 18 plus N of X intersection Y is how much? 23, correct na? 15 plus 8, 23. 18 plus N of X intersection Y, that implies N of X intersection Y, 23 minus 18, correct? 23 minus 18 is how much? It is 5. N of X intersection Y, N of X intersection Y is equal to how much? It is 5. Understand? See the problem? Understand? Next problem. Third problem. In exercise 1.6, third problem, in a group of 400 people, in a group of 400 people, 250 can speak Hindi, 250 can speak Hindi and 200 can speak English. 200 can speak English, full stop. How many people can speak both Hindi and English? how many people can speak both Hindi and English? See the problem first. Understand the problem. In a group of 400 peoples, 250 can speak Hindi, 200 can speak English. How many people can speak both Hindi and English? How many people can speak both Hindi and English? Same what we solved in previous two problems, same type problem. What we do? We write the sides first. Solution. Let not H, S, H represents set of people who speak Hindi. H represents set of people who speak Hindi. So alphabet H is there now, that's why I take H. If you want, you take A also, no problem. Then N of H has given. N of H is how much? 250. Correct na? I denote H is the set of people who speak Hindi. If you want, you take A is the set of people who speak Hindi. Okay. Next, English. E represents set of people who speak English. Set of people who speak English. So what are given? 200 can speak English. N of E. Alphabet E is there, that's why I take starting alphabet is E, that's why I take E. Okay na? E. One more he has given in a group of 400 people means N of H union E is how much? 400. 400 people. N of H union E. What he asks? How many people can speak both Hindi and English? So that means H intersection E represents set of people who speak both Hindi and English. Who speak both H intersection E represents set of people who speak both Hindi and what? English. That means to find what? N of H intersection E. To find N of H intersection E. Observe first carefully. Okay, we solve this one. Right here. We know that N of H plus N of E is equal to N of H union E plus N of H intersection E. Correct na? So N of A plus N of B is equal to N of A union B plus N of A intersection B. Then substitute all the values. 250 plus 200, 400, N of H intersection E. So how much? 450, 400 plus n of h intersection E. That implies n of h intersection E 450, 400. N of h intersection E is equal to what? 50. That means the total number of people who can speak both Hindi and English is 50. 50 people can speak both what? Hindi and English. Understand this problem? This is also very important problem. Observe carefully. So 50 people can speak both what? Hindi and English. Next problem. Fourth problem, if capital S and capital T are two sets such that S has 21 elements. S has 21 elements. T has 32 elements. T has 32 elements. And S intersection T has 11 elements. S intersection T has 11 elements. How many? Very simple question. How many elements does S union T have? How many elements does S union T have? See the question. You also solve. If S and T are two sets such that S has 21 elements, T has 32 elements, and S intersection T has 11 elements, he asks how many elements does S union T have? Okay. So give one solution. Give one. N of S is equal to 21. N of T is equal to 32. N of S intersection T is equal to 11. N of S intersection T is equal to 11. To find N of S union T, we know that N of S plus N of T is equal to N of S union T plus N of S intersection T. Correct na? N of S plus N of T is equal to, so I take, instead of A and B, I take S and T. Okay, N of S plus N of T is equal to N of S union T plus N of S intersection T. Substitute all the values. 21, correct na? 32 is equal to, we want N of S union T plus 11. So this is how much? 53, correct? 2, 1, 3, 3, 2, 5, 53. N of S union T plus 11. I shift plus 11 from right side to left side. That implies N of S union T is equal to 53 minus 11. So N of S union T is equal to how much? 42, correct? n of S union T. N of S union T is how much? It is 42. See the problem very carefully. So same type problem. N of S union T is equal to what? 42. Next problem. Next, fifth problem. In exercise 1.6, if x and y are two sets such that x has 40 elements, x has 40 elements, x union y has 60 elements and x intersection y has 10 elements. X intersection y has 10 elements. Full stop. What he asked? How many elements does x have? How many elements does, not x, it is y. Sorry, not x, it is y, because x has given. How many elements does y have? See the question. If x and y are two sets such that x has 40 elements, x union y has 60 elements, x intersection y has 10 elements, how many elements does y have? So solution, very simple question. Solution, given n of x, total number of elements present in the set x, 40, correct? Okay, n of x union y is how much? 60, and n of x intersection y is how much? To find, what do you have to find? N of y, correct? N of y. You also solve same problem. So we know that n of x plus n of y is equal to n of x union y plus n of x intersection y. N of x intersection y. Substitute all the values. N of x 40 plus n of y we have to calculate 60 plus 10, 40 plus n of y, 60 plus 10, 70, n of y, I shift 40 from left side to right side, 70 is equal to 70 minus 40, n of y is how much? 30, correct now? N of y is how much? 30. See the problem, very important problem. What he has given? He has given n of x union by n of x means total number of element present in x, total number of element present in x union y, total number of element present in x intersection y. What he asked? He asked the number of element present in y side. So we use n of x plus n of y is equal to n of x union y plus n of x intersection y. Means the total number of elements, how many elements does y have? The number of elements in y is 30. Correct? Next problem. Sixth problem. In a group of 70 people, 37 like coffee. 37 like coffee. 52 like tea. And each person like at least one of the two drinks. One of the two drinks. What he asks, how many people like both coffee and tea? How many people like both coffee and tea? See the question. In a group of 70 people, 37 like coffee, 52 like tea, and each person, this is very important concept, each person like at least one of the two drinks. So this 70 people likes at least one of the two drinks. If they like both the drinks or one drink, either tea or coffee, this means this sentence, what I underline, each person like at least one of the two drinks, this means or this indicates this is nothing but union of coffee and tea. This 70, the total number of elements of union, coffee and tea. Correct na? Okay. So 37 like coffee, n of coffee is 37, n of tea is 52. What he asks, how many people like both coffee and tea? Both coffee and tea means union or intersection? Intersection. Okay. What we do? We write the representation. We have to represent the sets. For coffee, I represent C set. For tea, I represent A sets. Solution. Very simple question. Solution. Let C represents set of people who like coffee. If you want, you take A set also, no problem. Then n of C 37. C represents set of people who like coffee. T represents set of people who like tea. n of t, n of t is how much? 52. In a group of 70 people, each person in this group, each person like at least one of two drinks means also given. Also given n of C union T is equal to how much? 70. Correct na? N of C union T is equal to how much? 70. To find, or else first we represent the set. Let C intersection T, correct na? Represents set of people who like both coffee and tea. Set of people who like both coffee and tea. That means we have to find out n of C intersection T. We know that n of C plus n of T is equal to n of C union T plus n of C intersection T. N of C plus n of T. So n of A plus n of B is equal to n of A union B plus n of A intersection T. Substitute all the values. That implies, right here, that implies n of C 37 plus n of T 52, 37 plus 52, n of C union T 70 plus n of C intersection T. Okay, then, so this is how much? 7 plus 2, 9, 89, 70 plus n of C intersection T. That implies n of C intersection T, 89 minus 70, n of C intersection T is how much? 19. N of C intersection T means the 19 people who like both what? Coffee and tea. 19 peoples who like both what? Coffee and tea. So understand this problem. It is also very important problem. Next problem. Seventh problem. In a committee, in a committee, 50 people speak French, comma, 20 speak Spanish, 20 speak Spanish, and 10 speak both French and Spanish. What he asked? We'll stop. How many speak How many speak? At least one of these two languages. At least one of these two languages. See the problem? It is also a very important problem. In a committee, 50 people speak French. So 20 speak Spanish. 10 speak both French and Spanish. How many people speak at least one of these two languages? At least one of these two languages means we have to find out n of French union Spanish. Okay, so solution. What we do, let F represents set of people. Set of people who speak. Which one? French. Set of people who speak French. He has given n of F is how much? 50. N of F is how much? 50. Next, Spanish. S we denote. Okay. S represents set of people who speak Spanish. So n of S is how much? 20. N of S is how much? 20. 10 speak both French and Spanish. Next line, F intersection S represents set of people who speak both French, I write here only, and Spanish. French and Spanish. That also given. That implies n of F intersection S is how much? 10. To find at least one of these two languages means n of F union S. We know that n of F plus n of S is equal to n of F union S plus n of F intersection S. Okay, we substitute all the values. N of F means that implies 50 plus n of S means 20. N of F union S that we want plus n of F intersection S that has given 10. $70 is equal to n of F union S plus 10. That implies n of F union S 70 minus 10. N of F union S is equal to how much? How much? 60. So that means 60 people can speak either of two languages, either Spanish or French or both Spanish and French. The total number of F union S is how much? 60. Understand? This is also very important problem. Next problem. Eighth problem. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. Okay, what else we will see? How many like tennis only? How many like tennis only and not cricket? Question mark. One more he has given. How many like tennis? Okay, see the question. Very interesting question. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. Firstly ask how many people like tennis only, not cricket. Like tennis, N of T intersection and means intersection, not cricket means not C dash. Here we find N of T intersection C dash. We will see how to find. And one more, we have to find out N of T. Correct now? We have to find out N of T. They like only tennis and not cricket. We will see this one. So what we do, we represent the sets C for cricket, T for tennis. Solution. Let C represents set of people who like cricket. N of C has given 40 and T represents set of people who like tennis. We have to calculate this one. Yes, na? Okay. So C intersection T represents set of people who like both cricket and tennis. That also given 10 like both cricket and tennis. N of C intersection T, it is 10. One more he has given in a group of 65 people. So N of C union T is equal to what? 65. To find, first one is already right. To find, I write once again, N of T and one more Set of people who like tennis only and not cricket. N of T intersection C dash. Not cricket. T intersection C dash. Okay. So we know that formula. We know that N of C plus N of T is equal to N of C union T plus N of C intersection T. Substitute all the values. 40 plus N of T is equal to N of C union T 65 plus 10. Correct? 65 plus 10. 40 plus N of T 75. N of T 75 minus 40. N of T, how much? It is 35. First one is over. Then second one. Set of people who like tennis only, not cricket. N of T intersection C dash. That means N of T minus N of T intersection C. Correct now? So we remove the set from tennis, both who like cricket and tennis. That means 35 minus 10. This is also one formula. N of T intersection C dash is nothing but N of T minus N of T intersection C. So how much? It is 25. So 25 people, that implies 25 people who like tennis only and not cricket. 25 people who like in 35, so tennis as well as both tennis and cricket. 25 people who like tennis only, that's why write N of T intersection C dash. 25 people who like tennis only and not cricket. See the problem. Very important problem. This is very important problem. Yes, now. So very important problem. See once again. N of the 25 peoples who like tennis only and not cricket. Okay. We stop. We continue the remaining problems in next class. Thank you.